Section 4-2, perpendicular and angle bisectors. Remember, the bisectors means that they're cutting something in half. A perpendicular bisector theorem says that if a point is on a perpendicular bisector of a segment, here's a perpendicular bisector right here. It's perpendicular because there's a right angle. It's a bisector because this half is equal to this half. Point X lies right on that perpendicular bisector. So if a point is on the perpendicular bisector of a segment, then it is equidistant, that means same distance, from the endpoints of the segments. So the endpoints of the segment are right here and right here. Segment AB has a perpendicular bisector, and the point X is the same distance from A as it is to B. The converse will go backwards. If a point is equidistant from the endpoints of the segment, if X is equidistant to the two endpoints, like segment DE here, then that means that X lies on the perpendicular bisector. That means that this segment right here must be perpendicular and must bisect the segment. So anytime you see that, you know you're going to have two equal parts right there. So looking at some examples here, this M lies on a perpendicular bisector of segment AB. Segment AB is being cut in half, and it's perpendicular to segment MP. That means that the distance from M to A is the same as the distance from M to B, so this would be 8. Right here, this segment NP is a perpendicular bisector to segment LM. How do I know that? Because the point N is the same distance to L as it is to M. If point N is equidistant, then that means that this is a perpendicular bisector, which means that 2x has to equal 4 and x has to equal 2. So that one's the converse. This one right here, what do we know? We know that this is perpendicular and that the segment is cut in half. So SR is the segment and TU is the perpendicular bisector. So that means the point T is on the perpendicular bisector, which means it's the same distance from T to S as it is from T to R. So that means that this half has to equal, or this segment has to equal this segment. So 10x minus 3 has to equal 5x plus 2. And then you can solve it for x. Minus 5x minus 5x, you get 5x, and then do plus 3 and plus 3. You get equals 5, so x equals 1. And lastly, for this one, what do you know? You know that this is perpendicular, but it's not necessarily cut in half, so you have to look at the other clues. PR is the segment, but Q, this point Q here, is the same distance from P as it is from R. Those are marked congruent. That's the converse then. If Q is equidistant from P and R, then that makes it a perpendicular bisector. So 12 minus x is equal to 2x. So when you add x to both sides, you get 3x equals 12. And then when you divide both sides by 3, you get x equals 4. Okay, so if a point is on the bisector of an angle, see how those two angles are the same right there? That makes this an angle bisector. Then it says that that point X, which is on the angle bisector, that point is equidistant from the sides. So the distance to this side is from X to A, and distance is always measured at a right angle to make sure it's the true distance. That distance 4 is the same as the distance from X to C, so that distance is 4 as well. The converse will work too. If a point is on the interior of an angle, if that point is equidistant from the sides, so here's X. X is equidistant to D and equidistant to F. That's the same distance by the congruent marks. That means that this X lies on the angle bisector. So when you draw that blue line, the angle bisector, you are actually cutting this angle in half. If you know that it's the same distance to each side, then you know that the angle is being bisected. So examples of that. Look at what you know. What you know is that this point, it doesn't have a name, but this point is the same distance to this side. It's got a congruent mark and it's at a right angle, and this point is the same distance to this side. That means that the angle is being cut in half. It's being bisected. So x would equal 70. That one was the converse reason. This one right here, what do you know? You know that 38 equals 38. You know that this is being bisected. Therefore, this point that's on the bisector has to be equidistant to this edge as it is to this edge. So 3x equals 12, which means that x equals 4. This one, you have to look for what you actually know. You know that this point right here is 5 away from this side at a right angle, and this point is 5 away from this side at a right angle. So you know that this point is equidistant to both sides. Therefore, it must be bisecting, or the line that it's on must be bisecting the angle. So 4x must be equal to 2x plus 20. So when you subtract 2x from both sides, you'll get 2x equals 20. And when you divide both sides by 2, you will get 10. Okay, so turn to the page on the back side, 4-2 practice. I want you to try number 1, 2, and 3 on your own, looking at your clues here. This segment, AC, that's the segment they're talking about. And this point B is on a perpendicular, there's a right angle there, bisector is being bisected. The AC is getting cut in half there. So this segment is a perpendicular bisector of AC. So look at those clues and see what you can figure out. So you should have noticed that the distance from B to A is the same as B to C. So we would say that 4x equals 3x plus 4. And that would mean that when you subtract 3x from both sides, you are going to get 1x equals 4. For this one, to find AB, then you just go and plug it in. 4 times 4, and you get 16 as your answer for that one. 16. And then when you go to plug it in for BC, you have 3 times 4 is going to be 12, and 12 plus 4 is 16. So you can tell that it actually is equidistant from both endpoints of AC. The point B is equidistant to A as it is to C. Try these 4 problems on your own. Click pause first, try them on your own, and then come back and check your answers when you've tried them. Okay, MO is a perpendicular bisector of blank. Well, MO goes this way, and here's the right angle. The segment that's being bisected is NP. So that means MO is a perpendicular bisector to NP. It's cutting NP in half. Find the length of MP. This point M is on a perpendicular bisector, so it's the same distance from M to N as it is to M from M to P. So MP would be 4.5. Find NO. NO, this point O is also on the perpendicular bisector right here. It's still perpendicular and that's still bisected. So the distance from O to P is the same as the distance from O to N, so that would be 9.5. And lastly, to figure out what NP would be, this half right here is 3.2, so this half would be 3.2. So the total from N all the way to P would be 3.2 plus 3.2, or we would get 6.4. Okay, try 8 through 13 on your own, hit pause, and then come back when you're ready to check the answers. M, this point right here, is equidistant, those congruent marks right there. So this congruent mark 8 equals this congruent mark 8. So M is 8 from the side KL, and M is also 8 from the side JK. How is KM related to JKL? KM becomes the angle bisector because the point M is equidistant to the two sides. That means that this angle is getting cut equally in half. So that's why I said that 3x has to equal 54. Therefore, divide by 3, x equals 18. And for number 12, what would be the measure of angle MKL? MKL is already 54. So we need to figure out now the measure of angle JMK and LMK. Well, remember all the way back to when we had whenever we had triangles, that 3 angles in a triangle always add up to 180 degrees. So if we have 90 degrees right here and 54 degrees right here, the total would be 180. So 180 minus 90 and minus 54. When you subtract all that, you should get 36 degrees, and that's the answer for angle JMK right here. JMK and LMK, they would both be 36 degrees. Okay, hit pause and try 14 and 15, then I'll show you the right answers. For number 14, you already have marked that 3x minus 2 is equal to 2x plus 4, so make that equation when you saw that you get x equals 6. Then to find BA, you just plug it in. 3 times 6 minus 2, you get 16, and 2 times 6 plus 4, you get 16. For number 15, it's different because there's no actual congruent marks on the sides, but if you had this reflexive side right here, you would have congruent triangles by angle side angle, and that would mean that this segment is equal to this segment. So I made 5x plus 3 equal to 7x minus 1. I solved it and I got x equals 2. Then to figure out EH and EF, I plugged it in. 5 times 2 plus 3 was 13, and 7 times 2, 14 minus 1 is 13. So I got 13 for both of them. Try these last two on your own. Click pause until you're done and then click play again. For number 16, I already see that this side or this segment right here is equal to this segment right here. So I'm just going to make 3x plus 6 equal to x plus 6. Subtract x from both sides and divide by 2, you get x equals 3. Now to figure out what ik is, from I all the way over to k, you have to plug in x equals 3. For this part, 3 times 3 is 9. But for the other part, 3 plus 6 is 9. So you really have to do 9 and 9 makes 18. For number 17, what do we know? We know that we have a reflexive piece right here. And so we have the hypotenuse leg theorem. So by corresponding parts of congruent triangles are congruent, you can make this angle equal to this angle. So you can have 3x plus 8 is equal to 4x plus 4, x equals 4. Then plug it into both and you get 20. Okay, go to Google Classroom and work on the assignment for tonight.